Hello, can you hear me? So? Okay, thanks. My name is Tudor, and welcome to the best joint talk at PyData Chicago.
Yes, the best and only joint talk at PyData Chicago. So Tudor and I work at Shiftgig, and we're going to talk a little bit about our experience productionalizing our first data science model at Shiftgig. This was the first time the data science teams and the engineering teams had worked together, and we ran into some issues along the way and came up with some best practices, and we'd like to share them with you.
So, I'm going to introduce myself. So I've been a software engineer at Shiftgig for about 2 years. I started off as a JavaScript engineer and moved on to Python about a year ago. And I should say that I'm not a data scientist.
And clearly I'm not a software engineer. I joined Shiftgig about a year ago as the first full-time data scientist, and my background is in physics and computational neuroscience. Since I was the first data scientist at Shiftgig, this meant I had a lot of opportunities to work really closely with the engineering team because they're pretty much my only peers, and they had to give me access to all the databases. And now Tudor will tell you a little bit about Shiftgig.
So just a quick overview. The main part of that Shiftgig offers is a digital marketplace that connects businesses with hourly workers. So we provide fully vetted workers that we call specialists with this mobile app that allows them to claim shifts based on their skill preferences and their schedule. And on the business side, for our clients, we offer tools to help them manage their event rosters, submit time cards, and rate and favorite specialists they'd like to see again.
Cool. So now I'm going to tell you a little bit about this project that we worked on, which was a reliability score for our specialists. So we created this score as a way to quantify the reliability of a specialist based on their history with us. There are two main features. One is a retention component. Do they stay on the shifts that they claim? And a completion component. Do they actually work the shifts that they claim? Currently, it's visible to the specialist on the specialist app with this gauge that you can see. It goes from not good to excellent. And the gauge changes daily depending on if their score has changed. We're not showing it to clients yet. We're still doing some experiments on how effective it is. Hopefully it's doing something. And we think this is something that can distinguish us from traditional staffing agencies. Traditional temporary staff agencies are still run with like phones and writing things down. So since we're a tech company, we have a lot of data, and we think we can leverage that to produce a smarter marketplace. So I'll tell you a little bit about how we developed the score. So initially, when we started this project, the data science team was working on it. So we used our intuition to develop the first components. We'd done a few studies on correlations in different parts of their work history. So we know that there's a correlation between dropping shifts in the app and not showing up to your shifts. So we knew we wanted this to be a factor in the reliability. So I came up with a few components and developed a few different formulas to test against. And the main way I tested these different versions was by checking the score distribution for all of our workers and looking at a lot of summary statistics like the mean and standard deviation. We knew we didn't want a score where everyone was failing because we thought that would be really depressing for the specialists. We also didn't want a score where everyone was doing really well because we wanted them to have something to strive towards. So we wanted a distribution that was sort of well-balanced where, you know, if you really were a good worker, you'd have a good score. If you were sort of in the middle, you'd have something to work towards. And if you were bad, hopefully you'll get fired. Because there are a few different components, I was able to test different weights for the different components and different time scales. So after looking at the distributions and talking with other stakeholders and thinking about the business considerations, we chose what we considered to be an optimal timescale and weights for the different features. At the same time, though, I knew these were likely to need to be changed in the future, so I wanted to make sure the software engineers left us flexibility to change these things once the score was in production. Okay, so then we had a handoff. Unfortunately, there was no ice cream. So I gave the backend engineers a Jupyter notebook with my SQL queries and my code for all of the formulas. To me, it was very clear what I was giving them. I was like, just query the database for these exact things that I've given you. Use these weights. These are the components I've decided on. Shouldn't be any controversy. Just implement them. And also, but leave me the flexibility to change these in the future.
While we're on the slide, please enjoy the off-brand minions that we have up there that we found that we could use for free. So at this point, myself and a few other software engineers came onto the project. We got an idea of what the requirements were, and we got the Jupyter notebooks. We had no idea what Jupyter notebooks were. We had never seen these before. So we realized we kind of had to. We had these components we had to implement, but we also had to think of kind of an overarching architecture for how the score framework is going to work, how we're going to productionalize it, how it's going to be made available to the specialists, if we're going to persist it, and so on. Yeah, we set up our stories, we narrowed our process, and then kind of the three of us engineers just started hacking at this. Our team came up with a couple of requirements that we had to deal with. First of all, we have to make sure the specialist could see their score, so have to be part of our viewable via our API. We wanted to persist the score history because we wanted data scientists to be able to take a look at trends of a specific specialist, how they've been doing over time, and kind of take a look at how the distribution of scores has changed with time. We wanted to have a really scalable implementation because we're a growing company. We're going to have more and more specialists. So we want to make sure that we can handle calculating the scores for a giant pool of specialists. We also wanted a flexible architecture where as the score grows in complexity, as now we only had 2 features, we'd be able to change the implementation of features and add more and more as we go. And finally, while this was going to be a service that calculates and persists the score in production, in the dev environment, it could also be used as a way for the data science team to kind of play around with the score and try different score distributions, add features, and so on. So it took a little bit of thinking, and we thought we came up with a pretty good solution. And we went to one of our favorite tools that we use at Shiftgig, Celery. How many of you guys have heard of Celery? Python Celery? Hopefully all of you have heard of Celery. Oh, okay. Celery, that's an asynchronous task queue that we use whenever we want to have a particular set of functionality that's executed in the deferred way or scheduled for a particular time. So one of the ways we use it, one of the examples I have for the way we use it at Shiftgig is when a specialist might claim a shift, we'll have a Celery task where in 24 hours we'll set such that we'll email them a notification that, hey, your shift is coming up, make sure you show up, you have your uniform and all that. That's one of the ways that we use it. But here, what's really nice about Celery is, first of all, is that it handles multiprocessing, so we can really parallelize our workflow, which helps us with a large amount of worker specialists that we're going to have to deal with. Another cool functionality of Celery is Celery chords. Celery chords allows you to link together what I might call child subtasks, such that when they're executed in parallel, once all of them are finished and the results are available, these results will be sent to a parent task that would execute something. So it's kind of a function that has multiple inputs, and with that it might do something else and return an output based on that. And that seems to fit a sort of something we might want to do for like a weight average, where we have multiple kinds of multiple inputs that come in, and we want to compute something in the parent task. And I have a little. I thought the chord kind of made sense as a musical chord as well, so I have a little chord in there. Many notes together, something greater comes out of it. Not sure if that's what they were thinking. Continuing with the musical kind of thinking here, we we decided on the final solution for our software, and we called it Bolero. Have many of you heard Ravel's Bolero? Familiar with it? A piece of classical music, maybe? So it's something that kind of starts off in a stately manner with only a few instruments, and then kind of builds up and adds more instruments and becomes more complex. So that seemed to both mesh with the fact that we're starting off with very few features and going to build up more in the future, but also kind of help. It was a good analogy for the way that these chords work and kind of fan out and fan back in and kind of grow in complexity. So we had we would have these daily bash jobs where we would get all of our specialists and create a giant chord for all of our specialists. And within within this chord, we'd have tasks that would start off chords for calculating the score. And the chords we made up of the various components that Nicole had sent us. What this allowed us to do was basically abstract out differences within the components, such that at the end of every cycle, at the end of every task execution, we'd be persisting a particular component value to the database, as well as the final score value. So that meant that at any time, if you wanted to look at the specialist score history, at any particular time, you'd be able to see the breakdown at a very granular level of what their score looked like at each of these features. So, and so this dealt with our persistence requirement, with our scalability problem, and the flexibility is there in the fact that you can have as many tasks in a chord as you like. We can simply add component 3, 4, 5, build that out, and it'll return and calculate the final score in that way. The final piece was to make this very configurable for data science, and that's where we made use of YAML configuration file that completely mirrored the Celery workflow that we had created. I'm sure some of you have heard of YAML. And some of you know what it stands for. Yes. Also, it used to stand for YAML 8 markup language. But that's what it stands for now. Yeah. I knew I'd get those confused. So what we did is that the entire score workflow is based off of a YAML config file. So what this means is that without having to change any Python code, the data science team would go in and basically change the weights of the configuration of any component, add and remove components, and be able to iterate very, very quickly on the score implementation without having to submit pull requests or to have to go through more complicated process of. It's very, very, very configurable. Now that we had the architecture in mind, it was time to actually implement ourselves the features that Nicole provided us. So, and keep in mind that what we were given was Jupyter notebooks from data science team, and we hadn't worked with Jupyter notebooks before. So our first impression was that this is very very kind of experimental code. This is stuff that they were trying out, and it's kind of like a template or a rubric that we can base our work off of. Which is definitely not what data science was thinking. So we're going through all the queries that we see in this Jupyter notebook, how the implementation. At some point we say, well, you know, one of these features, the implementation is kind of unfair. We don't think, we're software engineers and we've been in a company for a while, so we have some idea of what the business logic is like, and we think, it feels like we should really change this somehow and make it, and have a little tiny tweak to the way this is implemented. So the software engineers and I, we go into a Slack room, we talk about it, and we're like, okay, yeah, we're gonna change it. And with the handoff mentality, we didn't really communicate this to the data science team at all. So yeah, so trouble was brewing.
Or conflict. Yeah, so they made all these changes, didn't tell me, but at some point I got curious and checked the Bolero codebase. That's when I discovered these changes, and they were, from my point of view, very significant changes in the components. So we made the great decision to talk about this on Slack instead of in person. We all sit within 15 feet of each other, so we can all we can see each other. I don't know if you guys have ever had intense conversations on Slack. I like to call it like where you're rage typing, and then you get up and go to the bathroom, and like you have to not make eye contact with the person you're conversing with. It's really difficult. So in our Slack channel for Bolero, I messaged a few of the software engineers and was like, "What's going on? Like, you guys changed all this. But it feels like it happened behind the data science team's back. Like, what is happening?" So it got kind of intense. From my point of view, it felt like the engineers were upset that we had specific specifications for the features, and that didn't really make sense to me at all. I wasn't sure why they would be upset about that.
From our point of view, we definitely realized we should have communicated some things, but at the same time, we felt like, we have some interest and we have some knowledge of the business logic, and we thought, we wanted to make sure that our opinions were heard as well, and we would have a discussion basically on this, and we kind of felt like data science wasn't really hearing us out on what we thought was the best way forward with this particular feature.
Yeah, so I went home that day and I was super upset. I felt like my work wasn't being respected. I was like, why did Shiftgig even hire a data scientist? Like, if they're not going to use my work. And when I went home, I also reran the score with the changes the engineers had made. And shockingly, it changed the distribution. The main change was that although they thought they were making the score more fair, they actually ended up lowering the average score for all the workers, which was not something that the data science team wanted.
Yeah, and we didn't have the kind of nuanced knowledge to understand what the effect would be. So, yeah, very kind of sheepish reaction to that.
So the next day, we set up a meeting where we talked in person instead of on Slack. So it was me, Ty, the head of backend engineering, who I was talking to on Slack the day before, my boss, who's the head of data science, the VP of product, and the VP of engineering. So my boss and the VPs were kind of like, what the hell was happening yesterday? Like, what were you guys doing? So we all kind of agreed that we should have switched to talking in person earlier. Tone is really hard to figure out in typing. So I reported back that the changes they had made had dramatically changed the score distributions for all the workers and actually brought the mean score down. I explained all of the research that had gone into our choices for the weights and the different components and stuff. And Ty explained that he actually hadn't been angry on Slack. It just sort of felt like he was angry, and he has a serious face. So it's hard to tell. Yeah. And that engineering wasn't trying to undermine us. I think they didn't have a sense of all the work that had gone into our choices. And as Tudor mentioned, they sort of viewed Jupyter Notebooks as a template more than something that was set in stone. So we agreed that data science and engineering would go over the code together before anything was released to production to make sure that everyone was on the same page.
Yeah, and one of the things we wanted to make sure was that there was this sort of division between data science and software engineering, where one group was the thinker and one group was the doer. We wanted to be able to be part of the conversation, and that's the kind of thinking that we went forward with when we went about planning the rest of the project. In our stories, we made sure to include some sort of data science oversight into our implementation. We had these sort of regular check-in and reviews. We kind of had a run through of the entire code base with Nicole, and we were very excited to see how interested she was basically in what we were thinking of doing, and had a lot of really good ideas that contributed a lot. And this kind of all came together when we were about to productionalize this application, and we had to do some thinking on functional testing, load testing, and we wanted to make sure that we had everything that the final version of our code was exactly what data science expected. Yeah, so Nicole provided us with some data.
Prior to the release, I gave them a test worker set based off of my own code for them to test against, so that way we would know for sure that what I thought the components were matched with what they had implemented. And after that meeting, we all collaborated a lot more closely on the implementation. There were times when I was trapped in a room with multiple engineers trying to write SQL queries. It was very smelly and horrible. We were there for like 3 hours working on one query, and we couldn't even get lunch. So, collaboration.
Yeah, for my part, when I finally got the entire workflow running, I made sure to save the sort of a snapshot of the database that Nicole could go through and make sure the distribution matched what she expected, and to kind of check over her use case specific specialists that she had, the test workers that she had set up for us, and it worked out really well. And, we got it working. We're scoring specialists. They're seeing the score. Yeah.
Cool. So now we have a few takeaways. The first one is obviously Slack is really horrible for intense conversations. As I said earlier, tone is very difficult to assess in writing. We should have switched to talking in person as soon as things got more complicated or when somebody was confused, instead of just barreling through this Slack conversation. Because we were a startup, we have very limited conference space, so I think the lack of meeting rooms may have also contributed to this. We were just sort of like, well, there's nowhere for us to go. But I think even if we had just gone and walked around the block together, that would have been better than trying to write things and sort of everyone being really confused about what everyone's intentions were. Okay, takeaway 2. Document everything. I assumed that the engineers only needed to see the final version of my score formula. I didn't think they would necessarily be interested in all the work that had gone into choosing the different weights, which was definitely a mistake on my part. I don't really know why I thought that. Obviously, they know how to think. They're creative people. Not you. So I learned that the engineers wanted to be involved in the data science project, and they obviously had valuable contributions to make based on their prior knowledge and their superior Python skills. So definitely, I think if I had documented things and sort of shared things more along the way, we would have skipped some of these issues that we ran into.
The other side of this equation, sort of the complement, is to the issue of documentation is to ask lots of questions. If there isn't anything documented, when you didn't have a good idea of why decisions were made, it would have been really easy to basically get an idea of what the thought process was like for each feature we were going to implement. And because of the handoff mentality that we had, we just kind of assumed we're working in a silo, and data science had their own sort of priorities at this point, so we're kind of left on our own to deal with this.
Tudor sits right next to me, so he just had to turn his head 90 degrees.
The fourth takeaway, which is something that we've been working more towards at Shiftgig, is to involve stakeholders throughout the span of the project. Data science put a lot of work into the reliability score. They had a skill set and knowledge base that was absent on the software engineering team, and we were ill-prepared to understand some of the nuance decisions the data team made. So we really benefited from having that know-how, even if it's just kind of as a resource there in our Scrum meetings. To have data science there was something that was essential to getting the project running in the end.
Yeah, this is something we've really taken to heart at Shiftgig. Data science and engineering are obviously relatively close in the grand scheme of our company. We sit in the same space, we're on the same Slack channels, but we do a lot of work with other departments like accounting and sales and marketing. So we found that our projects go a lot more smoothly if we have representatives from those departments coming in and working with us during the whole length of the projects. Having someone come to the scrums every day and come to the planning so that everyone knows what's going to be delivered, what the problems are. So less of this handoff mentality that just leads to lots of confusion at the end.
And then on the more positive takeaway is that we can build something amazing together. Software engineering, data science, side by side. We both have complementary skill sets, and we work really well when we combine our domain knowledges.
Yeah. Working together, we can leverage all of the creative thinking that everyone's capable of as Shiftgig. Like everyone knows how to problem solve, and it's better if we work together instead of creating problems for each other to solve. We have plenty outside problems to figure out. Okay, so that was our talk. We want to thank all of our coworkers at Shiftgig. They had to listen to our practice talks. They had to actually work with us. Thanks to our bosses for letting us present. They wanted us to say that Shiftgig is hiring both data scientists and software engineers. So send them an email or talk to one of us after the talk.
Thanks to PyData thank you all for coming here. Really appreciate it. And we thank each other.
The question was how we document data science projects now. We definitely use doc strings and comment my code, which I wasn't doing before. But also, I've been writing reports for the internal data science team, which sort of explained all the experiments I had done and like made graphs of like the different weights and stuff like that. But I didn't give any of that to engineering. So after that, I was a lot more thoughtful about sharing that stuff and also writing documents in such a way that people without data science knowledge could sort of understand what was happening, or at least have references of things to look up. We use Google Docs. It's a pain in the ass.
Okay. So the question is, we used to have the handoff process, and but we're trying to transition to something new. And how do we handle making sure that we collaborate without having wall-to-wall meetings and crazy schedules where everyone's calendar is blocked off because they're in someone else's team's meetings? So I think so. We've gone through. We shifted to more of to a different kind of Scrum team setup where we will have a representative of a different team kind of there for just the 5-minute Scrum that we have on this particular process. And that's usually the length of their involvement on day to day. And that's where we'll bring up any questions that we have. Of course, there's always Slack to send off one-off requests, which of course we'd rather do in person than Slack. We learned something. And we have these sort of bi-weekly planning meetings that sort of domain-specific individuals who are working on a project will take part in. And so the extent of the time that's spent is basically 1 hour or 1 hour and a half a week or so.
Yeah, I would also say I think our mentality is more invite everyone, and then people can self-select out if they don't need to be at a meeting, and that's a better outcome than if people are left out of meetings. And also to not go into private Slack channels to talk about our projects. Thanks. The end.